Kaliya become the
We are going to begin the webinar. Is my voice is audible to all?
Yes, audible.
Okay. Good evening to everyone and welcome to this webinar on Montreal Protocol Advancing Climate Action. The Montreal Protocol, a landmark international agreement, has played a pivotal role in protecting our planet's ozone layer. However, its significance extends far beyond this. Today, we will explore how the Montreal Protocol is also contributing to climate mitigation efforts. We have a distinguished expert, Dr. D. Mohanlal, Professor, Department of Mechanical Engineering, Anna University, who will share his insights on the protocol's achievements, challenges, and future prospects. I am confident that this webinar will provide a valuable information and inspire further action to address the pressing issue of climate change. Now let us begin the webinar. I now request Dr. R. Sagaya Alfred, Senior Scientific Officer, Department of Science, Technology and Environment, to deliver the keynote address.
Am I audible? Am I audible?
Yes, sir.
Okay, thank you. So, happy evening to each and every one of you who are on this platform today. Really, it's a great pleasure to join in this webinar on World Ozone Day as we celebrate the 35th anniversary of the Montreal Protocol. And we all know that this year's theme, Montreal Protocol, Advancing Climate Action, which is more relevant because of the pressing urgent challenges due to climate change. We all know that the Montreal Protocol has been adopted in 1987 and it's a landmark international agreement which highlights the power of the global cooperation. And this protocol has been instrumental in phasing out harmful ozone depleting substances, say chlorofluorocarbons, hydrochlorofluorocarbons, and others. The success of this protocol has not only protected the ozone layer, but also significantly it has contributed to the climate mitigation. And if you see, it's a clear established framework for international collaboration, which includes reporting requirements, compliance mechanisms, financial assistance to developing countries. I request others to switch off or to please keep your audio, audio in mute position. Jodi Labs, Jodi Labs,
Yes, sir. We are in mute condition only.
please mute.
Yeah, we are in mute only, sir.
Oh, okay, okay. So to continue this, again I repeat, it's a clear framework for our international collaboration, including our own reporting requirements, compliance mechanisms, as well as financial assistance for developing countries. Crucially, it fostered a global sense of solidarity with nations uniting to achieve a common goal. And if you see, primarily it aims at protecting the ozone layer, and subsequently the Montreal Protocol has also advanced to take care of our climate actions. Many of the substances it phased out are potent greenhouse gases that contribute to our global warming. And by eliminating such potent greenhouse gases, the protocol has also reduced the greenhouse gas emissions and helped to mitigate our climate change. And it has also inspired other international agreements like the Paris Agreement, which address similar global challenges through collective actions of all the countries. However, if you see, still the challenges remain in the aspect of both Montreal Protocol as well as the subsequent Paris Agreement. The reasons may be illegal trade in ozone depleting substances and the rise of new greenhouse gases like HFCs, which pose significant concerns. So, to address all these issues, we must strengthen our enforcement as well as we have to work to phase down HFCs under the Kigali Amendment. Despite of all these obstacles, the Montreal Protocol offers a valuable lessons on international cooperation and science-based decision making. By continuing to build on such successes and addressing emerging challenges, we can advance climate action and secure a sustainable future. So, by this, I conclude, and I would like to say that we all have to make, or we all have to abide, we all have to stringently follow the rules and the regulations and to try to mitigate the global emission so as to save our future environment. Thank you for the opportunity provided. Thank you.
Thank you, sir. I now request our speaker, Dr. D. Mohanlal, Professor, Department of Mechanical Engineering, Anna University, to give the presentation on Montreal Protocol, Advancing Climate Action.
Good evening to all. At the outset, I consider it as a great pleasure to be with you all, maybe online, to deliver this lecture on Montreal Protocol, Advancing Climate Action. And I'm also thankful to the organizers for giving me this opportunity and inviting me to make this presentation. I would like to further advance. I hope my screen is visible.
Yes.
My screen is visible.
Yes.
Yes, sir, the screen
Yes.
is visible.
Okay. Okay. Sorry for the interruption. The presentation contents will be mainly focusing on the Montreal Protocol, advancing climate action, and what it really means to us in this context. Then the progress India has made on the ODS phase out over this period of time since it became a party to the Montreal Protocol. And subsequently, since 2019, India is also committed for phasing down the usage of HFCs, which has led to the focused advancement in climate action. And implications of Kigali amendments on India, and what is the way forward in terms of technology, in terms of challenges, in terms of opportunities, and ultimately a little bit of mention on sustainable refrigeration, and next will be concluding remarks. We are all fully aware about the Montreal Protocol, which regulates the production and consumption of nearly 100 man-made chemicals called as ozone depleting substances, which is ODS. Though the ozone depleting substances are being produced and consumed by various sectors, The ozone depleting substances consumed in the refrigeration sector is more than 50% of the total ODS that is released into the atmosphere. And therefore, the refrigeration sector is more responsible for stopping the usage or stopping the depletion of the ozone layer. And these chemicals, when they are released into the atmosphere, they damage the stratospheric ozone layer, which is a shield that protects humans and the environment from harmful levels of ultraviolet radiation from the sun. And this was adopted internationally on 16 September 1987, and it has been ratified universally. And as it was pointed out in the keynote address, the Montreal Protocol has been quite successful in its implementation and achieving the objectives originally slated. And in this Montreal Protocol, India became a party in the year 1992. And since then, India has been working on the ozone depleting substances that were responsible for depleting the ozone layer. As far as the refrigeration industry is concerned or sector is concerned, the CFC group of refrigerants played a major role because of their high ozone depleting potential. And as per the commitments of the protocol, first the CFCs had to be phased out. The schedule given for developing countries, which is called as A5 country in the protocol, was 2010 for phasing out CFCs. But India could phase it out in 1st August 2008 itself, which is a major achievement. India has also completely phased out production and consumption of CTCs, carbon tetrachloride, which is a chemical that is widely used not only in refrigeration industry but also in foam industry, in electronics industry. Similarly, halogens, which are used in firefighting as a firefighting agent, and all these substances were phased out by January 2010. So, having accomplished a major milestone in the commitments towards complying on the Montreal Protocol, currently ozone cell, which is a cell functioning under the Ministry of Environment and Forest of Government of India, and that was responsible for implementing or making the country comply with the commitments for the Montreal Protocol. Currently, the cell is engaged in phasing out of production and consumption of the next category of chemical, which is HCFC, hydrogenated chlorofluorocarbon, with an accelerated phase-out schedule as per the Montreal Protocol. When we say accelerated, originally when the protocol was given, the phase-out for A5 countries with regard to HCFCs were slated until 2040, and that has been accelerated. Now let's see how this Montreal Protocol is advancing climate action. Montreal Protocol, of course, is mainly to protect the ozone layer, as it was observed that the ozone layer has been damaged heavily because of these ozone depleting substances, leading to the entry of ultraviolet B radiation from the sun into the Earth's atmosphere, which was quite harmful, which is quite harmful to the human beings, to the animals, to the plants, etc., etc. The main attempt was to reinstate the ozone layer. The idea was to stop consuming or to stop releasing ozone depleting substances into the atmosphere with the understanding that the formation of ozone is spontaneously happening by nature. And if we stop destroying or depleting the ozone layer, automatically it gets replenished. And this has been verified by the observations made by the World Meteorological Organization. And it has been found that the, the uh, replenishment of the ozone layer is happening, and it is rectified in a very faster pace. But then how this climate action, global temperature rise, all these things are coming into action. First, let's see what's climate action. Climate action refers to efforts taken to combat climate change, and climate change refers to long-term shifts in temperatures and weather patterns, which we are all observing nowadays. The rains don't come in the right time. In the expected time, rains don't come, but all on a sudden rains come. There is severe drought in many places. Many difficulties are encountered. These are all said to be because of human activities since 1800s. That climate change is happening primarily due to burning of fossil fuels like coal, oil, and gas. The average temperature of Earth's surface is now nearly more than 1.2 degrees centigrade warmer than it was in the late 1800s, that is before industrial revolution. And it has been said in many of the UN reports that limiting global temperature rise to not more than 1.5 degrees centigrade would help us avoid worst climate impacts and maintain a livable climate. So all that we could see is, if we are using the CFCs, HCFCs, they do ozone depletion, and not only ozone depletion, they are also found to be global warming gases. Not only these are global warming gases, apart from that, the CO2, the methane, the nitrous oxides, these are all becoming a group of gases which forms a blanket at the top of the Earth's surface that prevents the escape of reflected thermal radiation to escape from the Earth's atmosphere. And they are re-radiated back. As a result, the temperature of the Earth is continuously increasing. So ozone depletion is one phenomenon, and global warming is another phenomenon. The factors which are responsible for these two phenomena seems to be common. The the refrigerants, these substances, ozone depleting substances, are also global warming substances. Now, when we come to global warming, there is direct and indirect. Direct emissions of these global warming gases, otherwise called as greenhouse gases, cause direct global warming. Any burning of fossil fuels can release CO2, and CO2 is also a global warming gas which can cause more rise in temperature. As a result, the temperature rise of the universe can happen because of direct emissions of these global warming gases, or by any act of burning fossil fuels. As a result, what are the consequences of climate change? We have experienced water scarcity, many parts of the world, severe fires, rising sea levels, flooding, melting polar ice, catastrophic storms, and declining biodiversity. So these are all the consequences, and this Montreal Protocol has been instrumental in advancing this climate action also by addressing ozone depleting substances as well as phasing down the HFCs very recently. These HFCs, though they are not ozone depleting, they have been substituted in the place of ozone depleting substances when we initially phased out the CFCs for for phasing out of the ozone depleting substances. Meaning to say, in the refrigeration side, the typical refrigerant R134A is a HFC, which played a major role in substituting CFC12 in many of the appliances. Similarly, there are many HFCs that have been substituted in the place of CFCs as well as HCFCs are not ozone depleting, but they are global warming. Now, India's progress on ODS phase out and HFC phase down. This is the accelerated phase out schedule for HCFC as per the Montreal Protocol. ODP of HCFCs, hydrochlorofluorocarbons or hydrogenated chlorofluorocarbons, are somewhere just below zero point 0.2. In that, HCFC 141B was having the highest ozone depleting substances in the group of or in the family of HCFCs. So that was targeted first in the phase out schedule, and by 2020 January, it is completely phased out. Now, HCFC phase out is ongoing since 2013. And as far as the total HCFCs are concerned, we are having nearly in the baseline 1,600 ODP tons of HCFCs, and these HCFCs have to be phased out in a phased manner. And by 2030, we should have reached 2.5 percentage of our baseline value. And by 2030, all usage of HCFC in new appliances will be stopped. Appliances will be completely removed, and but those appliances which are already functioning will continue to function. And for the service of those appliances, this 2.5 percentage of HCFC will be used. Now, in this HCFC phase out management plan, the stage 1 has been completed from during the period 2012 to 17 with a support of total funding of US dollar 21.3 million. Now, these funding are coming from the multilateral fund, which is part of the Montreal Protocol to support A5 countries, that is developing countries, to transit into new technologies which will be required for shifting from CFC technologies or to phase out ozone depleting substances. Now, in this HPMP project, the agencies participating are the UNDP, GIZ, and UNEP. And what happened? The objective for the for the stage 1 was to phase out of this 1,691 ODP tons, 341 ODP tons had to be phased out. And this has been successfully done with HFC 141B in the puff sector, supported by UNDP. In 15 large size enterprises were assisted, with 8 domestic refrigeration manufacturing enterprises along with that. Similarly, in the RAC sector, training programs were undertaken by GIZ, and enabling activities for preparing handbook and on the national regulations for monitoring and controlling on the production and use of ODS in India done by UNEP. Everything with all these 3 agencies participating, the overall benefit in phase 1 was the net direct emission of 30 71,260.5 tons CO2 equivalent of this HCFCs were phased out. Similarly, in phase 2, during this period, the HPMP stage 2 happened, and in that time also the three agencies participated in the three activities. Overall, 769 ODP tons of HCFC was phased out. And this has brought in a direct reduction in direct emission of 8,530 metric tons of CO2. And HPMP 3 is now from 2024 onwards with a funding of US dollar 450,000, and it is to achieve our targets for 2025 and 2030. If our targets for 2025 is that in the baseline, that is in 1600 tons ODP tons, we will have to use only 32.5. It will be the limit. So to achieve this, we should have transited into new technologies, new refrigerants other than HCFCs. So to achieve this 2025 target and for achieving 2030 target, this HPMP3 will be working. And in that, 580 ODP tons of HCFC production and consumption is to be phased out. Now, the progress has been happening as per the expected milestones, and 2020 this third stage also will see its success by the end of 2030. And phase down of HFC is something which have started to happen under Montreal Protocol since 2019. As the Montreal Protocol was ratified by India in 1992, since then, the protocol parties had meeting of parties in various countries, and these periodic meetings will be helpful for reviewing the progress of various parties in the protocol. And whenever there is a significant change or amendment in the protocol, that has to be accessed by or accepted by the party countries. So now here are certain dates of accession to Montreal Protocol and its amendments by India. So here we can see a bunch of amendments which has been accepted by India. And in 2016, the Kigali Amendment came into force, and India ratified it in 2021. As a result, now what is this Kigali Amendment? Kigali Amendment, in that meeting, it was projected that though ODS are phased out, the substitutes which are brought as non-ozone depleting refrigerants or substances are actually global warming substances. And these global warming substances do not corrupt or do not break down the ozone layer, but they are heavily global warming. Therefore, the substitutes brought in, predominantly these HFCs in the place of CFCs and HCFCs, have to be now phased down. Now, when we say phase out and phase down, there is a difference. The global warming is required to some extent as given by God in nature itself. If the global warming is not happening, the tendency of the universe is to drop down in its temperature and it becomes uninhabitable. So we need global warming, but what is happening because of global warming gases is excessive global warming. Therefore, these global warming gases have to be phased down and not phased out. And that is why it is said phasing down of HFCs. Another group of hydrofluorocarbons were introduced as non-ozone depleting alternatives, but they are global warming gases. HFCs are now widespread in air conditioners. Many of the air conditioners, the room air conditioners used, are using HFC 32, which is R32. Its global warming potential is not as high as HCFC 22, But this global warming potential is nearly 675. The refrigerators are using 134A in the place of CFC12. But now we have transited from that also into hydrocarbon 600A. But earlier, when it was phased out in way back in 2003 and 2008, those period, lot of HFC 134A refrigerators have come. Now, these chemicals do not deplete ozone layer, but they have global warming potentials ranging even up to 14,000. There are a bunch of variety of HFCs and HFC blends which are used in various appliances. And these have very high global warming potentials. Therefore, uncontrolled growth in HFC emissions leading to challenges, efforts to keep global temperature rise at or below 0 degrees, below 2 degrees centigrade in this century will be difficult if it is increasing. So urgent action on HFCs is needed to protect the climate system. Now, this was the major thrust in the Kigali Amendment to the Montreal Protocol. The pathway to implement HFC phase down is reduce dependencies on high global warming alternatives, increase adoption of low GWP, energy efficient technologies, and HCF as part of HCFC phase out. So while phasing out HCFC, also do consider to phase down the HFCs and use low GWP refrigerants. Such a smart approach can achieve the Montreal Protocol's objective and also achieve a climate co-benefit along with that by reducing CO2 emissions as well as other global warming gases. Now, Kigali Agreement is an amendment to the Montreal Protocol. Now, the salient features, it is a legally binding agreement between signatory parties with non-compliance measures. It came into effect is 1st January 2019. India ratified it in 2021. It has shown a considerable flexibility in approach while setting phase down targets for different economies, accommodating their developmental aspirations, different socio-economic compulsions, and scientific and technological capabilities. So it has to accommodate the developmental aspirations of various parties, that is, various countries. As a result, the countries were grouped into three groups. The first group, second group, they have different phase down schedules. India is in the third group and it has got a different phase down schedule, which is reduce it to 15% of 2024-26 levels till starting phasing down HFCs by 2028 and reduce it to 15% of 2024-26 levels till 2047. It also has a provision for a multilateral fund for developing countries for adaptation and mitigation. The TEEP will take a periodic review of alternative technologies. So we need to phase down HFCs, but the refrigerants, the technologies, the methods that we adopt have to be really sustainable, that it does not cause further global warming or any other environmental degradation. Now, Kigali Amendment and India has agreed on a lenient scale as it consumes only. This is very important. Out of the total HFCs world consumption, India shares only 3%, whereas USA shares 37 and China shares 25. Therefore, our schedule is quite lenient, and we are also having ambitious Make in India programs, and the growth of Indian economy is also quite significant. Naturally, when economy is booming, the cooling loads and cooling requirements also are rising. Therefore, we have to have a balance between the growth in the economy. At the same time, the environment should be also preserved. Now, implications of Kigali Agreement on Indian industries. There are financial implications, there are technological implications. Financial, When we shift from one technology to another, the cost incurred by the company in terms of changing the machinery, in terms of making new products, in terms of training the manpower, etc., increases. Technological implications are also there, for which we need to have good research. In this juncture, India Cooling Action Plan given by the Ozone Cell by Ministry of Environment and Forest of Government of India brings in a different perspective. It is actually a very big document which I have shrunk into a single slide. The concept is economy of any country should grow, but when economy grows, cooling demand also grows, but the demand can be moderated by codal practices. For example, taking a building, the building cooling load need not be continuously increasing by adopting different norms like ECBC norms, green building concepts, etc., etc. The cooling demand for a given built up area can be brought down significantly. Therefore, when the economy grows, the spatial requirements of building also grows. But because we have adopted good codal practices in construction of buildings, the heat ingress into the building can be reduced and the load can be reduced and the cooling demand can be reduced. Now, even the unavoidable rise in the cooling demand can be met with energy efficient technologies. Therefore, the technology in building, making the building, construction of the building should be revised to reduce cooling demand. And to meet the cooling demand, the technology of cooling also has to be improvised by a bit with more efficient technologies. Now, even with more efficient technologies, the minimum requirement of energy is there. This incremental requirement will definitely amount to additional cost, and the cost additions also can be met from green renewable energy, which is a sustainable means of evolving the required cooling. Now, for all these building practices, then for energy efficient technologies, for the provision of systems, everything requires R&D, and that is the primary thrust that we get from the India Cooling Action Plan. We have to evolve methods, we have to accept new concepts and proceed. Now, on a positive side, these requirements of phasing down of HFCs and requirements of new refrigerants brings in some new refrigerants which we call as HFOs, hydrofluoroolefins are there, which can substitute HFCs, and not only HFOs, the hydrocarbons which are there for a long time, but we were cautious in using, or the mindset is not prepared to accept that refrigerant because it is flammable. But there is another natural refrigerant which is ammonia, which is also a very good refrigerant, but it is toxic. Now, here, how do we tackle all these issues? This is the challenge here. Reducing HFCs have got challenges and opportunities. Reducing HFCs requires adopting safer alternatives. Reducing HFCs amounts to adopting innovative practices. That's what we will have to do. Now, when we talk about flammability issues with regard to hydrocarbon, there are so many hydrocarbons which are found to be very good refrigerants. They have got good energy efficiency. They are environmentally friendly refrigerants, but only thing is they have some flammable issues. These refrigerants characteristics as flammability and toxicity are characterized under ASHRAE 34, A and B for lower toxicity, B for higher toxicity, and flammability 1, 2, 3, 3. And now there is a subset of 2 which is 2L, low lower flammability. In 2, there is a 2L, which is lower than 2 category. So this we need to, for example, if we say A1 as a refrigerant, that means toxicity is low, it is very friendly, and it is not flammable. Suppose if it is A3, there is no toxicity, but it is highly flammable, which is the case of most of our hydrocarbons. Now, coming to substituting HFCs with hydrocarbons, here I would like to make a small mention about what could be done and what has been done from our side also. R22 was originally used for room air conditioners. The global warming potential was 1700, which is coming under category A1. R32 was introduced as a substitute, expecting phasing out of HCFC very soon. And now 32 is a major player in room air conditioner. GWP is 675 and it is coming under A2L category, though it is not as flammable as hydrocarbon, but it is also flammable. So flammability wise, it is worse than 22. Global warming wise, it is better than 22. Therefore, it can be only considered as an intermediate because global warming potential 675 is of major concern. Now that we want to remove, phase down HFCs, we have to look for alternatives. 290 is a very good refrigerant which works almost on par with R22. Its global warming potential is 3, but only thing is its flammability is category is A3. It is not toxic, but it is highly flammable. But then there is some certain, there are a lot of research work which has gone all over the world, and in our university also we have done research on that. But the IIR informatory notes one of the safety measures required to prevent potential fires or explosions with flammable refrigerant is to minimize charge and leak. Charge has to be less. If the charge quantity is very less, for any flame or any fire accident, there are 3 things: fuel, oxidizer, and spark. Fuel and oxidizer mixed in the right proportion. Only if all these 3 conditions satisfy, there is a fire. So if the charge quantity can be minimized, the fire accidents can be avoided, and we need not worry about that. How can we reduce charge quantity? Most of the charges are stored in heat exchangers. Refrigerant charge can be lowered by reducing internal volume of heat exchangers, and the availability of mini and micro channel heat exchangers has helped this to achieve low charge quantity in a big way. At Anna University, we have tried 290 as a substitute for 22 in window air conditioner as well as split air conditioners. And we have compared it with R22 and found to be more energy efficient. The charge quantity was just 300 grams. Remember, 300 grams in an air conditioner is not a big deal, provided we know how to handle it. Let us remember that we have already connected 14 kg of LPG, which is containing propane and isobutane, both are A3 categories and mixture, and that is connected directly to the stove. We are able to handle it. Originally, when LPG stoves were brought in the market, there was a lot of apprehensions, but now everyone is happily and safely using it. Here and there, 1 or 2 fire accidents happen, and for that reason, we are not removing LPG from our cooking. Therefore, we should also have the mindset to accept these refrigerants, but should know how to handle that refrigerant. The risk assessment studies were also done in our university, and it is found to be having remote chances for a fire hazard if safety precautions are followed. Now, one suggestion for operating it safely is there are many methods. A solenoid valve at the exit of condenser operated by a reliable leak detector in the indoor unit can alleviate fire hazard even if there is a leak inside. So the problem is the stove is actually kept in the kitchen and nobody is sleeping in the kitchen. But this air conditioner is put in a bedroom and people are sleeping. But we need to remember the indoor unit is inside where the evaporator is kept, and the outdoor unit is outside the room where the condenser. Nearly 60% of the refrigerant is mass is available in the condenser while it is running, because liquid condensation happens there. Total mass nearly 60% is in the condenser. So if at all there is a leak in the condenser, it goes only outside. If it happens inside, if there is a sensor and the sensor could trigger a solenoid valve and stop flow of refrigerant from condenser into the evaporator, this can be safely handled. Only thing, the mindset should change. The modified system with smaller condenser having 6.35 mm diameter, this is our experience. Capillary of length 820 mm and diameter is 1.524 mm, and condenser air phase velocity of 3.52 meter per second. Operates successfully with enhanced cooling capacity and COP at an optimum charge of 300 grams. Now, these charge limitations, everything are available in these standards. For want of time, I'm just rushing. And all these things can be safely done. Similarly, we have tried R1234YF, which is HFO, which is an alternative for 134A in MAC, mobile air conditioning system. 134A has a global warming potential of 1430, whereas 1234AF, it is 4. We have extensively tested 1234AF in MAC test rig. But only thing is, as it is actually, it can be used as a retrofit refrigerant, but not as a drop-in retrofit. If you use it as a drop-in retrofit refrigerant, the efficiency is not that good. But only thing is, we introduced a liquid suction heat exchanger, and accordingly the TXV was tuned. By tuning the TXV and by introducing a liquid suction heat exchanger, this 1234YF can be made to work more efficient, or the cooling capacity was 17% higher and COP was 6.5% higher for 1234YF. Therefore, MAX systems can be successfully retrofitted with 1234YF, possibly with a suction line heat exchanger and tuning TXV. But only thing is, tuning of the TXV, only thing is, this 1234YF also has got an issue with TFA. What is this TFA? Certain refrigerant emissions into the atmosphere result in decomposition products which could be harmful to Earth's ecosystem. Some of the current and alternative synthetic refrigerants can produce significant amount of this trifluoroacetic acid. But these acetic HFOs are short-lived. Therefore, this TFA is not going to be a big issue for the next few decades. That's what the observation says. But still, what will happen to the environment in the longer run will have to be assessed. So, a word of though it is a very good substitute with a low global warming potential, in order to make it sustainable for a longer period, we need to check that also. This is only projected as a caution on using that. But as of now, UN is permitting it to be used as a, there is no negative remark on with regard to the TFA, but that has to be watched. There is another beautiful refrigerant, which is ammonia, natural refrigerant. Here, the history of refrigerant way back from 1830 to the future is given from, and you can see in every stage ammonia continues to travel with the group. It is never phased out. The simple reason is it is highly energy efficient. It has got no global warming potential and no ozone depleting potential. So, it can, whether it can be safely used. Yes, we have apprehensions because of the toxicity. It cannot be used in domestic systems. But domestic systems also can be redesigned and redeployed appropriately to do this. At Anna University, a 3TR system has been tested. We here also, to handle the toxicity, the charge quantity should be reduced. We can make ultra low charge systems by redesigning the system circuits. A plate heat exchanger was used as evaporator to chill water, and water in turn was used in a fan coil unit to cool the air for air conditioning application. I mean, a mini channel heat exchanger is used as air cooled condenser. A capillary was used as an expansion device. Usually, hand expansion valve is used. So here we used automatic capillary expansion device. In order to make the system critically charged, we used the capillary as the expansion device, and the receiver in usually prevailing in the ammonia systems was removed. As a result, we could achieve an ultra low charge system. What we could achieve is it was just a specific charge of 55.8 grams per kilowatt, qualifying the system as an ultra low charge system with a COP of 3.54. Of course, this study was not done very in depth, some preliminary study which was done as a PG level project work. Whereas that 1234YF and hydrocarbon for air conditioners were conducted in detail as a doctoral level research study. So, ammonia is eco friendly, energy efficient, safe refrigerant too. Now, this ammonia has got many special attributes. I would like to point out one important issue. At least 6 international airports are air conditioned with ammonia. Long time back itself. See, way back in the late 90s, once I went to a dairy plant, and in the plant, when I entered inside, there was so much of ammonia smell. When I inquired, it was found that they were using ammonia chillers for air conditioning also, along with ice plant and water, along with milk cooling. So part of that load for was sorry, part of the capacity was utilized to meet out the air conditioning load. But ammonia leaked, it came into the water, and the smell was terrible. But nowadays, the joints, the bracing techniques, everything have improved, and ammonia can be safely handled. And a typical example for that is already airports are running with ammonia systems for air conditioning. Therefore, if we could handle ammonia appropriately by suitably modifying, redeploying the systems components appropriately, it can be used successfully. So next, now I brought in 3 substitutes for to replace HFCs or to phase down HFCs. Hydrocarbons could be used, HFOs could be used, ammonia could be used. These are all technological advancements, and these technology advancements have to be what we exploited appropriately, and we have to do so. Then comes with all these ifs and buts and pros and cons of various technologies and refrigeration, we need to be aware of one thing: sustainable refrigeration has to be achieved by all means. RAC, refrigeration, air conditioning, and heat pump applications plays a key role in sustainable development, contributes equipment contributes to climate change through direct emissions of global warming refrigerants and indirect emissions from energy consumed during lifetime operations. The important issue is some adverse effects are real and immediate. Example, flammability and toxicity, and may be avoided by design measures at an additional cost. This is very important. The green premium is a factor to be considered when we try for alternative technologies to save the environment. So this additional cost, how much is the additional cost? One should know. Some are near term on climate and may be avoided by proper refrigerant selections, and others are currently under further evaluation, which is a case of TFA. Like that, we have got various issues, but we need to find the balance between growth that is contemplated as well as the safety that is required for the humans as well as for the environment. It is important to balance the benefits and risks of refrigerant selection, including known safety and environmental impacts, being mindful of areas of scientific uncertainty. RACHP sector will continue to play an important role into the sustainable future of mankind with a focus on efficient cold chains and comfort applications. Based on these considerations, standards have been developed and has been discussed in the RTOC 2022 report. Standards and methods to estimate sustainability of refrigerants have been discussed in this report in detail, and that will be a handy tool for further research work and understanding about the technologies. CO2 equivalent emissions include direct and indirect emissions. Direct emissions may be reduced through leak minimization and technician training. So these are all there. Now, finally, when we attempt for various methods to save the environment for as climate action, we need to be careful, exercising caution. There is one issue which is going on called geoengineering. For the first time, scientific assessment panel examined the potential effects on ozone of the intentional addition of aerosols into the stratosphere known as stratospheric aerosol injection. SAI has been proposed as a potential method to reduce climate warming by increasing sunlight reflection. So they are injecting aerosols in the stratosphere to cause reflection of sunlight so that it does not come inside and heat. But the panel cautions that unintended consequences of SAI would also affect stratospheric temperatures, circulation and ozone production, and destruction rates and transport. So this warning is there. Why I am presenting all this? The researchers and technocrats, engineers should be aware of all these things when we attempt to make sustainable development goals. Thus, it's needless to say, let all developmental as well as escape measures which we try to achieve our targets, let them be sustainable. The concluding remarks, technically, CFCs have gone, HCFCs are to be phased out by 2030 or 2040. The two dates I already said. Ozone layer is getting replenished and expected to be reinstated very quickly, and a great success indeed for the Montreal Protocol. Global warming leading to climate change is being tackled through multi-pronged efforts by parties. Efforts need to be improvised through use of existing refrigerants that are eco-friendly but are considered unsafe, for example, ammonia, hydrocarbons, etc. A different mindset to accept flammable and toxic refrigerants as working fluids inside the appliances, but with suitable safety measures to handle if released inadvertently is needed. Remember, LPG connected to a burning stove is being accepted and handled for so many years. Innovative measures to reduce cooling load in systems needed. Innovative technologies to enhance, this is what I talked about, India Cooling Action Plan, needed to operate with less power and less CO2 emissions. Use of renewable energies to be promoted through green premium policies. When we try to attempt to use all these innovative technologies, the initial cost will definitely be more. But the regulations from government, the support from government, the subsidies from government should support such green premium activities through green premium policies. Green hydrogen and fuel cell technologies will be a great solace for the future energy needs, and we are into it already through the green hydrogen mission. Concluding remarks on accomplished goals, the UN-backed scientific assessment panel to the Montreal Protocol on ozone depleting substances, quadrennial assessment report published every 4 years confirms phase out of nearly 99% of banned ozone depleting substances. If current policies remain in place, ozone layer is expected to recover to 1980 values before the appearance of ozone hole by around 2066 over the Antarctic, by 2045 over the Arctic, and by 2040 for rest of the world. That ozone recovery is on track according to the latest report is a fantastic news. The impact the Montreal Protocol has had on climate change mitigation cannot be overstressed. Over the last 35 years, Protocol has become a true champion for the environment, said Executive Secretary of the United Nations Environment Program in Ozone Secretariat. So I am through. Let us join together to save the God-given environment to live happily. Thank you very much. I'll be happy to answer questions.
Thank you for sharing your valuable knowledge with us, sir. Participants are now free to ask questions to our speaker. Yes, sir. Amala Govindasamy.
Yes, ma'am. So this is a very good eye-opening for us. It's a very nice presentation. Thank you so much, sir. And
Thank you.
what kind of innovation needed for this? And
Innovation.
government can help for this, for particularly for the IT industry or some other industry.
Yeah, see, as I told, there are variety of technologies available to us which we will have to use safely, and we have to do away with the apprehensions on the various refrigerants or on the various technologies. The natural refrigerants can be used to a large extent, but safe handling has to be ensured. For all these, there needs to be additional cost provided. Now, how do we ensure? For example, let's say all government buildings should have only natural refrigerants. If a policy is made, that will amount a terrible cost for the government now. But it is nothing wrong. A stitch in time saves nine. Now, if we are protecting the environment, it is going to be helpful for the future generation. And that is the concept of this Green Premium Foundation. There are a lot of information which has come, and it has been initiated by Bill Gates, I think. So this Green Premium concept, we should definitely think, and that should be supported by the government. That is my consideration.
Thank you, sir. Thank you so much.
Sir, there is one question in the message section.
Which slide?
Mr. Pachamuthu has given one, he has asked something. What kind of measures or policies taken in Tamil Nadu for climate change, particularly ozone layer protection?
In Tamil Nadu, there are a lot of measures taken by the government, but specifically on refrigerants, I'm not able to say. But on the usage of green energy, there are various schemes of the chief minister himself to train people for enabling the government officials to go green at various districts. And there is a project which is going on in our university under our Institute for Energy Studies. And that project helps to train such people for green initiatives under the Chief Minister's funded project. And these people will be deployed in various districts of Tamil Nadu, and they will be providing the necessary data to the government for translating our methods and technologies and our approaches to become more green officially.
Participants, some more questions if it is there, you can ask our speaker. Sir, other question from Preeta John. What are the refrigerants targeted by HPMP stage 3?
Yeah, that I have in stage 3. I presented in the beginning itself. It is predominantly HCFC 22, HCFCs in general, and 22 is to be phased out. It was there. 141B was first targeted, and now it is HCFC 22.
The next question from Chemfab Alkalis Limited. What is the timeline imposed to stop the usage of R22, sir?
Yeah, I think you can refer the timeline was presented as a slide. I will just show that. You can see it in there. This is the timeline. So now we are in, I think my screen is visible. I am presenting that phase out schedule.
Yes, sir, it
This
is
is
visible.
for, yeah, this is for HPMP, HCFC phase out management plan. The baseline was considered to be our production in 2009 to 2010, which is considered to be, which is measured to be 1,609 ODP tons. And that has been phased out stage wise at various years. And now at 2025, we should reach the 32.5% of the 1,609 ODP tons level. And by 2030, it should come down to just 2.5 percentage. But we are all aware of the fact that our air conditioning or conditioners in the market is rising like anything. Therefore, when refrigerant 22 or HCFCs are phased out, definitely it is being picked up by the HFC, right? As of now, HFC 32 is a refrigerant available in the market. Similarly, we have in Godrej HC 290 also, but it is not very common, or people have much apprehension to buy that. But I would say that hydrocarbon being more eco-friendly and more energy efficient, the mindset of people, the public should change, and for which some more public awareness on how to handle HCs, how to handle safely the hydrocarbons, and bring in more safety norms in the manufacture of hydrocarbon refrigerator air conditioners, and that has to be made or known to the public, so that we become more green. Because 32, though it is used comfortably now, its global warming potential is 675. So we need to come down. I hope I answered your question.
Yes, sir. Any other participants having any other questions? Okay, sir, then we can wind up the webinar. Thank you for answering to all the questions patiently. I
Thank
now
you.
request Thiru K. Kalamegam, Environmental Engineer, Department of Science, Technology and Environment, to give the vote of thanks.
Yeah, I should also thank all the participants for the patient hearing, and I also thank once again the organizers for giving me this opportunity. Thank you very much.
Thank you, sir. Good evening to everyone present here. As we conclude today's insightful webinar on Montreal Protocol, Advancing Climate Action, it is my privilege and honor to deliver the vote of thanks. First and foremost, I would like to express our heartfelt gratitude to our esteemed speaker of today, Dr. D. Mohan Lal, Department of Economics, Professor and Chairman, Department of Mechanical Engineering and University Chennai. Sir, your expert talk provided us with a comprehensive understanding of the Montreal Protocol, protocol's pivotal role in climate action. Your knowledge and insights are certainly enlightened and inspire us all. Talking about various aspects of what is depletion, study from Montreal Protocol, EGALA agreement, uh, National Cooling Action Plan. So you covered a variety of aspects related to this subject. Thank you so much, sir.
Thank you, sir.
A special thanks to Dr. R. Sadayal, Senior Scientific Officer of DST, for delivering the keynote address and setting the tone for this important discussion. I would also like to thank Ms. R. Madi for a warm welcome address, which helped to kickstart this program in a very positive note. And my appreciation goes to all the participants of this program, the participants from various industrial sectors, from various institutions, educational institutions, government departments who have joined us today. Uh, Participants, your active participation and engaging questions during the question session and this discussion. And it made this event truly interactive and meaningful. Last but not the least, I would like to thank the organizing team of Puducherry Climate Change Cell in the Department of Science, Technology and Environment, all those who work behind the scenes to make this event a success. Thank you all once again. Have a wonderful day.
Thank you, sir. We can now wind up the webinar session, sir. Thank you all the participants for joining this webinar. Thank you one and all.
Thank you.
Thank you, sir. Thank you all.
Thank you.
Thank you, sir.
Thank you all. Thanks. Yeah.